Hello everyone, Mr. John from Areteem Institute with this week's Thursday Tidbit, continuing from last time about Sudoku sums and some problem solving you can do with the variants of these puzzles. I would recommend you check out that video linked in the description below for some of the details. We're going to really focus on what we need to answer our question of the week this time. So check out that last video for some of the other things that I'm going to just quickly talk about today. So, review of a normal Sudoku, right? Digits 1 to 9 in every row, every column, every 3x3 box there. Now, one of the things we determined last time is that the sum of all of the digits in the grid is going to be 405. This is a quick thing, right? Every row, column, or 3x3 box, you can say sums to 45. 45 times 9 is 405. Again, details in the last week's video there. Now, the puzzle we're focused on here has a lot more going with it. So we have normal Sudoku rules, row, column, 3x3 grids. We also have this restriction on this 2x diagonal. We have this kind of greater than symbol in the puzzle. But for today, I want to focus on these cages. So the cages all have unique sums, and the digits can't repeat in cages. So these numbers will come up, but just as a little bit of example of what the cages are, right? We have this 4 cage here, 4 cell cage. There's actually 4 of these 4 cell cages. So we have those there. We also have some 2 cell cages. So there's a 2 cell cage here, here, and here. So there are 3 4 cell cages, 4 4 cell cages. There's a couple of cells not in cages, and that's actually our question of the week, right? From last time, the video there. There are 2 cells that are not in these cages. So those are going to be, of course, here and here. And we want to determine the values of those cells. Now, this is not immediately clear that this is possible at all, right? It's not clear that this is possible. That's the magic of this puzzle. We're not going to worry about solving the rest of the Sudoku, right? I have a link in last week's video if you're more interested about that. Let's focus on this question here, which is, if you want to solve the Sudoku, where you should start. But let's just focus on this because it has some very interesting mathematical properties that allow us to solve this there. Now, let's start by listing some facts from last time or facts you could determine from this. And this is a general strategy for solving difficult problems. Look at what you know. So our facts here are things we determined last time, but these are also basic facts you could come up with when solving this question. So, sum of all of the digits in the grid is 405. I already mentioned that. Now, what about basic facts about the grid, right? The grid has 2 cells that are not in cages. Those are the ones we want to figure out here. There are 3 2-cell cages. I highlighted those. 4 4-cell cages. I highlighted those. The rest of them are 3-cell cages. There are 19 of that there, right? One good thing if you want to check your work. How can we check our work? Not totally checking it, but just as a way to make sure that this makes sense. Well, what if we add up the number of cells? We have 2 cells not in cages. We have 2 3-cell cages, right? We have 4 4-cell cages. And then the rest of these are 19-cell cages. Well, what if if you add all of these things up? 2 plus 6 plus 16 plus 57, right? If you add all of this up, you will get 81. Why is that a check? Well, it's a 9 by 9 grid, so we have 81 digits in total. Now, here is the important fact that we had from last time. This is going to be the key thing. There are 19 possible different sums for a 3-cell cage. Remember, all of the cages have to have different values, and these are 6 up to, right, if we go all the way up, we have up to 24 in this scenario, right? 6 comes from 1 plus 2 plus 3. That is the smallest possible sum. 24 comes from 7 plus 8 plus 9. So there are 19 of those. And here some alarm bells should be going off, right? When you solve a question, look for these seeming coincidences. Those coincidences often aren't coincidences and are key to solving the question. We have 19 possible sums. There are 19 3-cell cages, meaning that every single one of those cells has a different sum, and we know what they are in some order. One 3-cell cage is a sum of 6, one is a sum of 7, all the way up to 24. Now, let's start doing the math of these sums. So, our 3-cell cages, right? We have 19 of those. We just got done mentioning, right, that these are 6 up to 24. So these sums in total are, right, up to 24. So this is an arithmetic sequence, right? We know that there are 19 of these. So if we look at the average of the terms, we have 6 plus 24 divided by 2. On average, every term is 15. 15 times 19 is going to be 285 there. Now, let's do a little bit of keeping track in the kind of side here. So in the side, I want to start with our total, right? Remember that our total was 405. So if we do 405 minus 285, right, we have 120 left over. And I want to keep track of this leftover as we do the different cages and things like that there. So right now, we know that there's cells that sum to 285, and so we have 120 to go. Now, what about our 2-cell cages, right? There are 3 of these 2-cell cages there. Now, remember that every cage has a different sum. So, for example, if we start looking at a few of these, what if we said, well, could we have 2 and 5 in that cell, right? Well, they sum to 7. Wait, that doesn't work, right? We already used 6 up to 24. So these have to have, right, a sum of less than 6. What's the maximum you could get with 2 cells? Well, the maximum you could get is 17. So in fact, sum less than 6. Well, we could get 5. We could get 4. 3 is already 1 plus 2. So this has to be 3 plus 4 plus 5, right? We talked about this minimum a little bit last time there, right? But now we know that those cells are 3, 4, 5. Their sum is 12. So keeping track of our leftovers, we now have minus 12, and we're left with 108. So let me just move that 120 down here then to highlight our 108 at this point. Now, 108 seems like a lot left, right? We have our four cell cages and our last two cells. That's all that's left over in this scenario. But let's think about this a little bit, right? Let's think here of the 4-cell cages. We've already used sums up to 24. So now these sums have to be greater than 24. And now you might start to see how things could be looking up. They have to all be 24 or higher than 24. Well, 25 times 4 is already 100. What if we actually looked at the minimum of these, right? 25, 26, 27, and 28. This is the smallest those sums could be. But wait a second, this is 100 plus 1 plus 2 plus 3. This is already 106. Why is this 106 relevant, right? And remember, this is the minimum possible. This is the smallest 4 sums there. But if we subtract that off, we are left over with 2, right? So there might be a little trial and error here. You could say, well, what if we tried one of them being 27 or something, or 28 and 29 and something like that? Well, that's not going to work out. Why? And this is finishing everything up right here. Well, what about these last 2 cells? What's the smallest number we can put in a grid? Well, with doing the minimum of these 4 cages, we were left with only 2. And so 2 for 2 cells, right, tells us that each cell equals 1. There's only one possibility there. Each of those cells has to be 1. We have to put 1 in the puzzle there and solve things from that point. So, right, with all of these different sums, right, there's actually more we did. We did show exactly what the sums are in the 2, 3, 4 cell cages. If you were solving the Sudoku, that would be relevant there as well. But, right, answering our question, you actually have enough information by narrowing down these choices, looking at the minimum values. The cells that are not in cages have to be 1, finishing our question of the day. Okay, that does it for this week's video. Like I mentioned, check out last week's video if you want more information about the puzzle. I give some links there for you to be able to solve the puzzle that way too. Otherwise, stay tuned for a new topic next week. Subscribe to make sure you get all of the updates, and it really helps us out that way too. Otherwise, I'll see you all next time. Goodbye, everyone.